Okay, so for today's lesson, we're going to go ahead and start here at the weekly agenda. You'll be going down to week 7. It's the week that we're in. We're going to go to Wednesday, October 5th. Today we're going to be going over some acceleration calculations. To do that, we're going to be going over the equations first, and then we're going to go ahead and go through some independent practice problems you'll be working on your own. So we're going to go ahead and start by clicking on the acceleration equations. You guys remember you got a password to open this stuff, and the password is ERBE1124. And if we take a look at this first set of equations, you'll notice that there are some things that are not new to you. You've seen velocity and time before, but we're going to go ahead and write down what these variables are, or what they stand for, here on the side of your paper. So go ahead and take this paper out. Let's go ahead and write everything in. A is for acceleration, and the units for acceleration are meters per second squared. The VF is for final velocity, so go ahead and write that in, final velocity. And the units for that are meters per second. The VI here stands for initial velocity. Units again are meters per second. And then the change in T here, remember this triangle stands for change in, delta, is the change in time, and that's measured in seconds. Okay, so these are the variables that we're going to be using in this problem. Again, it's just basically going to look at the change in an object's velocity over a certain amount of time. We'll divide those two to get the acceleration of that object. Right, so that's the first equation. The second equation here uses the exact same variables. It's just been rearranged to solve for the final velocity of the object. So this might be a problem where they gave you what the speed was to start, they gave you how fast it was accelerating, and they gave you the change in time that it did that for, and you can actually calculate how fast the object would be going at the end of that acceleration period. The last equation here is a little bit complicated looking, but it's really not that bad. You're just solving for the change in position, or the displacement. So again, change in x equals displacement. Okay, and all the other variables here are the same. Again, this is in meters. All the other variables listed here are things that you've seen before. The acceleration we just talked about, the change in time, the initial velocity would be the velocity you start at. And then this last one, again, change in time, would be in seconds. So the second equation would be an equation you would use if you're trying to find how far something had gone if you knew the acceleration, the time, and the initial velocity. Okay, so we're going to go ahead and go to the practice problem. So let's go to the weekly agenda, click on independent practice for acceleration. Let's go ahead and maximize this and take a look. Guys, please remember to put your name and date on these papers so that you don't get them mixed up, or I don't lose them or recycle them for not having a name. This first problem, it says a sumo wrestler, it should say named, I have a typo here. Sam is squatting in anticipation for the start of his match. When he finally hears a signal to start, he leaps out at his opponent, and just before they make impact, he has reached a velocity of 2.3 meters per second. If it took him 1.2 seconds to reach that velocity, what acceleration did Sumo Sam achieve? Okay, so first thing we always do, or that I always have told you to do, is to identify the numbers in the problem. So 2.3 meters per second. It's meters per second, so you know it's a velocity. Over here, seconds tells you that this number is a time. And then we go ahead and start writing our given information. So this first thing I'm going to write is the time. It's the 1.2 seconds. This 2.3 meters per second is actually going to be the final velocity for the sumo wrestler, because this is the velocity he has just before he makes impact. The velocity that he started with should actually be 0, because he was squatting there waiting to start. So his initial velocity is 0 meters per second. The unknown here, what we're looking for, it says what acceleration did Sumo Sam achieve. So this acceleration is going to be our unknown. The equation for finding acceleration, we know from our equation sheet, is going to be acceleration equals final velocity minus initial velocity divided by the change in time. So we'll go ahead and plug these numbers in where they belong over here in the equation with our substitution step. It should look like this. It should be acceleration equals our final velocity of 2.3 meters per second minus our initial velocity of 0 meters per second divided by our change in time, which is 1.2 seconds. Alright, from here, we're just going to go ahead and do the calculations. 2.3 minus 0 is actually 2.3, and then we just divide by the 1.2, and we get an answer on your calculator. You should get 1.916 repeating. Now, there's two sig figs in these numbers, so we're going to show 2 in our answer. Our answer should just be, go ahead and write acceleration equals 1.9 meters per second squared. Alright, so that's our answer for the first problem, and that's just a very simple acceleration problem where you're given the time, the final velocity, and the initial velocity. Alright, let's go ahead and look at the second problem on here. For this second problem, it says a plane starts at rest. Okay, so that's a key right there. It's starting at rest, which means it's not moving, so zero velocity. So this is going to be our initial velocity right there. It says that it undergoes an acceleration of 4.8 meters per second squared. So this 4.8 will be our acceleration. And then it says it does that for 15 seconds. So that's going to be our time. So in the given step here, we're going to go ahead and write in the stuff. It'll be initial velocity equals 0 meters per second. The acceleration is going to be 4.8 meters per second squared. And the time that it does that for will be 15 seconds. The unknowns here, they want to know what speed it was when it took off, so that's our final velocity. And they want to know how long the runway must be, so that's a change in displacement, or a displacement. So we're going to be solving for VF, and then we're going to be solving for change in X. The equations for those two things we just went over. So if you look at your equation sheet, you'll notice that VF, or final velocity, is equal to your initial velocity plus your acceleration times your time. The second equation for change in X is going to be change in X, or displacement, is equal to 1/2 your acceleration times your time squared. Notice this is in parentheses, so you should do this first when you're actually doing your operations. Then we're going to add that to your initial velocity times your change in time. Okay, so this is our second equation for displacement. Our substitution step is going to be VF for this first equation, final velocity, equals 0 meters per second plus 4.8 meters per second squared for the acceleration times the time of 15 seconds. So basically in this first problem we're just multiplying 4.8 times 15. This square right here, some people will square the 4.8, but that's just for the units. You don't have to actually square anything here. The meters per second squared is just saying that the seconds have been squared. You don't have to actually square the number. Alright, now the second equation here, if we fill that in for displacement, would be displacement equals 1/2 times the acceleration, which is 4.8 meters per second squared. Again, you don't have to square this, times the time, 15 seconds, squared. Now you do have to square this 15 before you actually do everything else in this part of the problem. You'll add the initial velocity, which is 0 meters per second, times the 15 seconds. Alright, now when we actually solve these, and you do them in your calculator, for final velocity, we're going to go ahead and take that 4.8 and multiply it by the 15 seconds, and you get an answer of 72 meters per second. Okay, so that's the answer for the final velocity. For the change in position or displacement, when we go ahead and do this in our calculator, I always start with the 15. So I would take 15 and square it here. And then we're going to multiply it by 4.8. And then we're going to multiply it by 1/2. Okay, so this comes out, when you do this side right here, it comes out to be 540. And then we're going to add it to this. But anything times 0 is 0. So we're going to be adding 0 here. So our answer is going to remain 540 meters. Okay, so the runway for this plane was 540 meters long, and the final velocity of the plane just before it took off was 72 meters per second, which is extremely fast if you think about it. 72 meters is a pretty long distance, and the plane is covering that in just 1 second. Okay, so that's how you would solve all the practice problems that are going to follow. Make sure that you show the guess method. Remember, you're getting 1 point for showing each of these steps for a total of 5 points per problem. And if you have any questions, I might not be here for this class. I'm at a training, so you'll just have to go ahead and either email me or show up to tutoring in the morning at 7:50 a.m. All right, guys, hope you enjoyed it, and I'll see you tomorrow.